This conference will now be recorded.
Bucketing in Hive. So I think in the previous session I spoke about partitioning. Now I'm going to talk about bucketing. So before talking about bucketing, I'll talk a little bit about the disadvantage with respect to partitioning. Sometimes, suppose let us say that I wanted to partition my data and I'm trying to partition my data based on geographical location, such as country. Now we are already aware that there are some countries in the world which occupies huge population, right? So if that is the case, then we'll have larger partitions. So there are 4 to 5 countries in the world which occupies almost 70 to 80% of the total data. And also we are aware that there are some smaller countries in the world which will have only smaller partitions. So the point is very clear, right? So the data is not evenly distributed. Some partitions having more data, some partitions having less data, right? So that's where we have to balance out the data, right? So if the data is not evenly distributed among the partitions, it is called as data skew problem. So that's where we can use bucketing. So bucketing will make sure that the data is evenly distributed. Let us directly move to the hands-on, then I'll come back to this. So I'll open my Cloudera Kickstart view. I'll open the terminal. I'll launch Hive. Terminal, set title, give it as Hive. Click on view and zoom in. So first, let me see the list of all the databases, show databases. I just have only default database. I'm going to create a new database. Create database if not exists. Suppose I want to create a database with the name called as Hive_bucketing. I can see the list of all the databases. Let me switch to Hive_bucketing database. And I don't have any tables right now. So I'm going to open one more terminal. If you can just click on this icon, you should be able to open one more terminal. Let's do that. So terminal, set title. Suppose I just wanted to use this for any of the HDFS or Linux commands. Click on view and zoom in twice. And I have my data available in my downloads folder. I'm in my downloads. I have this file called as orders. So based on this, I have to create a managed table called as orders_stage. Let's do that. That is my first step. So I'm going to right click on the desktop, create document, empty file, Hive bucketing. Let's create a staging table. So create table, orders_stage. I'm going to define my column names, order ID, which is nothing but an integer, order, customer ID, which is order date, which is of timestamp type, on order customer ID, which is of integer type, order status, which is of string type, and then I can say row format, delimited, fields, terminated by comma. So this should be enough to create a staging table. Let's copy this, go to the Hive terminal and paste it. Show tables. I have this orders_staging table created. Let us load the data into this table. I'm going to use this file to load the data into that table. I'm going to use load command. Load data local in path, home Cloudera downloads, home Cloudera downloads. So here we have to give the file name, which is nothing but orders. Also, we have to mention into which table we are trying to load the data into. We are trying to load the data into orders underscore staging table. Let's copy this and let's load the data into the orders underscore staging table. Let's query the staging table. Select star from orders underscore stage, limit 10. So I have the data populated in orders underscore staging table. So what have we done till now? We have done two steps. One is create a manage table with the name called as orders underscore stage. We have done step 3 where we have loaded the data into the table called as orders underscore stage. Let's focus on step 2 where we wanted to create a bucketing table with the name called as orders underscore buck, and we will also mention the number of buckets as 8. So
Can
let's do that.
Sorry, I have a doubt. Can I ask now or like later?
Sandeep, I preferably take questions only in the chat box. You can put your question in the chat box. I'll make sure I'll answer your question.
Okay.
Yeah. So the first step is I have to enable bucketing. So I'll tell you how to enable bucketing. So Hive space hyphen is set and try to grep for bucket. So I'm trying to run Hive query on Linux terminal. This will try to get me all the properties which contains bucket in it. So this is connecting to Hive. You can see this first line. It is getting me all the properties which contains bucket in it. We are interested in this property, hive.enforce.bucket. Right. So just copy that property, set space that particular property name. It's showing us false. Now I'm going to make it as true. So you can see that it has been modified to true, right? So a lot of people forget this step and they think that bucketing is not working, right? So let's actually try to create a bucketing table now. I'm going to create a bucketing table with the name called as orders underscore buck and with the number of buckets as 8. Let's do that. I'll take this query so that I can modify it. My bucketing table name will be orders underscore buck. So remember, this is a bucketing table. Hence, I have to mention on which column we are trying to do the bucketing. That I can specify by using clustered by and then a column name. That is, I wanted to do the bucketing based on order ID column. Also, we have to mention number of buckets into 8 buckets. Let us copy this. Show tables. I have this bucketing table created. Let us describe that. Describe formatted orders underscore buck. So you can see all the columns here, and more importantly, you can see that the number of buckets is showing as 8. You can also see the column on which the bucketing is done. So it's done on the column called as order ID, right? So that's how we create a bucketing table. Now let's move on to step 4. The step 4 is insert all the data from the orders underscore staging table to the orders underscore bucketing table. Let's do that. I'm going to write insert query to do the same. Insert into table. What's the table name? Table name is orders underscore buck. From which table? From staging table. Select star from orders underscore stage. Let's copy this. Go to the Hive terminal, clear the screen, right click and paste it. This will take some time. Let's wait. So one entire question here. So the entire question is, how many number of reducers can be seen if you're trying to load the data into bucketing table? The answer is 8. So why 8? Because if you remember, we are setting the number of buckets as 8, right? So that's the reason why you would see number of reducers are also 8 whenever you try to load the data into the bucketing table. Not so much important, but chances are there that this might be asked in the interviews. Just remember that. So, and of course, you can see that number of files is showing as 8 because we have mentioned the number of buckets as 8. Now let us go to the HDFS location and verify the contents there. So I will get this location, right click, copy it, DFS space -ls -h, right click and paste it. So I want to show the output clearly. I wanted to zoom out here, click on view and zoom out, rerun it again. Maybe I have to further zoom out 1 minute. See here clearly, exactly there are 8 files. Look at the numbering, 0 to 7, totally 8 files. These are all files because you can see it's showing us hyphen here. And moreover, look at their sizes. Their sizes are also almost equal, right? So that's the important point with respect to bucketing. When you do bucketing, you're going to get the equal distribution of the data into the existing buckets. And by the way, what is a bucket? It's nothing but a simple file. So whatever you're seeing here, each of this is nothing but a bucket. One more inter question which you might get, let me put a point there. So remember that partition is nothing but a directory, right? Partition is nothing but a directory. What about bucket? Bucket is nothing but a file. Remember that. So a lot of people may make mistake here. When you create a partition, it will create a corresponding directory in HDFS. When you create a bucket, it will create a corresponding file in HDFS. As we have mentioned 8 buckets during that bucketing table creation, you can say 8 files here. Each of these files is nothing but a bucket. So let us check the contents in these buckets. I'll take the first bucket, DFS space -tail, right click and paste it. I'm trying to check the contents of this file. So let me just take some of the sample records, right click, copy it and paste it here. Also, I'll try to pick up the data from the next one. So there is a calculation involved to figure out the number of buckets. I'll talk about that shortly. So if you observe here carefully, every record contains the order ID. So what's the order ID column from each of these records? The first column. First column is nothing but the order ID column. So the first column represents the order ID column, right? So let's try to get the order ID column from the first record. So what's the order ID from this record? 51,688. I'm going to divide it by 8. So what is the meaning of this percentage symbol? This is going to get me the remainder, right? So I'm talking about getting the remainder from this order ID. I'm dividing the order ID divided by 8. Why 8? Because number of buckets we have mentioned is 8. So how much will this be? I'm interested in getting the remainder. Hence I'm using percentage here. So I'm going to my local machine. I'm going to launch Python. Again, don't worry about running this step. So this step is an extra step to get you more knowledge. I just want to show you how exactly it works in the internally. So 51,688. 51,688. Get the remainder. It's showing us what? It's showing us 0. So similarly, get the remainder from the next record. What's the order ID? 42,984 divided by 8. Right. So let's see what the remainder will be. Just a moment. 42,984. Again, the remainder is showing as 0. Right. So let's put the remainder as 0. What about from the next record? 21,496 divided by 8. You can also do this calculation. It should also be coming as 0. I think 21,496 is the value. Let's use that. That's getting me 0. Right. So observe here carefully. All these are getting me the remainders as 0. Right. So as all these are getting me the remainders as 0, these records are placed into this bucket which is having 0 here. So similarly, let's try to calculate the remainders from the next set of records. What's the order ID from this? 42,929 percentage 8. Let's see this value. 42,929 divided by 8. It's showing as 1. Right. And similarly from the next record, what's the order ID? 42,937 divided by 8. It's showing as remainder as 1. Again, for the next record, what's the order ID? 51,705 divided by 8. 51,705 divided by 8, showing us 1. So have a closer look here. All these remainders are showing as 1. Right. So that's why we are getting all the records into this bucket which is having 1 here. So whatever concept that we just spoke about is called as hashing. Right. So hashing is the concept that is used internally to distribute all these records into the respective buckets. Right. So let's go back here. So how bucketing works? So internally bucketing uses hashing concept, whatever just we spoke about. It applies the hashing function in the bucketing column, which is nothing but ordered column. And also one inter question that you have to remember is how do you create a bucketing table? So in the interviews, you have to remember this. You have to say that okay, we are going to use clustered by on a bucketing column, and then we are going to specify into number of buckets, let's say 8 buckets or whatever it is. Also, we have learned that bucket is nothing but a file. So in a table directory, each bucket is just a file. Also, we have seen that it's going to distribute the data equally. All the records will be distributed among the existing buckets equally. The other thing is fine here, but I would like to do one improvement here. I wanted to sort the data. So right now it's not sorted clearly. So I'm going to sort the data as well, and I'm going to apply the bucketing mechanism also. Let's see how to do that. So now I'm going to follow these steps. So step 1 is already done. We already have a staging table with the name called as orders_stage. Step 3 is also done. We have already loaded the data into the staging table. Let's focus on step 2. So create a manage table with the name called as orders buck sorted. That is bucketing with sorting enabled in it. And then we have to mention the number of buckets as 6. So let's do that. First step is we have to enable sorting, otherwise it won't work. So I'm going to grep for a property which contains sorting in it. So we got the results here. So I just wanted to point you to the exact property that I'm going to use. So this is the one that I should be using. Hive.enforce.sorting. So make sure you set this property if you wanted to see the bucketing with sorting enabled in it. So a lot of people forget to set this property and they see that sorting is not working. Make sure you set this property, only then sorting will work. I'm going to modify it to true. Check the value showing as true. So let us creating our bucketing table with sorting enabled in it. So the table name will be orders box sorted with 6 buckets. Let's do that. So I'm going to take this query and I will paste it. And I'm going to rename this table to be orders sorted. Number of buckets is 6. And I'm going to specify sorted column also, sorted by order ID column. Let's copy this. Go to the Hive terminal, right click and paste it. So we are trying to create a bucketing table with sorting enabled in it. Show tables. I can see this orders box sorted table. Let's describe the same, describe formatted. Orders box sorted. So certain important points that you have to observe here is, as we have enabled the sorting in it, you can see under table parameters, you can see sorted bucket columns prefix set to true. Also, you can see the usual information such as number of buckets is showing as 6. Bucketing column is order ID column. Unsorting column is order ID column. So we're done with step 2. Let's focus on step 4, where we wanted to insert the data from the orders underscore staging table into the orders underscore buck sorted table. Let's do that. So I'm going to use my insert query that we already have defined. Let's copy this and paste it here. So my table name changes. It should be orders box sorted. Apart from the rest of the details remain same. Copy it. Go to the Hive terminal, right click and paste it. This will take some time. Let's wait. So again, one inter question that you might expect here is, what would be the number of reducers when you load the data into the bucketing table? Have a look here. It's showing us number of reducers are 6 because they have mentioned the number of buckets is 6 here. Also observe here carefully, number of files is showing us 6. Let's go to the HDFS location and verify the same. I'll get the location from here. Right click, copy it. DFS space hyphen ls hyphen h. Right click and paste it. So couple of important things to notice. One is the number of files is showing us 6 because you can see the numbering 0 to 5, totally 6 bucketing files, and these are all files because these are all starting with hyphen. And look at their sizes are almost equal. So each of these files that we are seeing here is nothing but a bucket. So let us see whether hashing is working fine or not. So I'll take the sample data from the first bucket, dfs space hyphen tail. Right click and paste that path and try to get some sample records. Let me also try to get some sample record from the next one. So first step is I wanted to make sure whether the hashing is working fine or not. So let's try to get the order ID from this record. 68,736 percentage 8. Sorry, not 8, 6, because the number of buckets is 6 that we have mentioned. So let's see what will be the remainder for this. 68,736. 68,736 percentage 6. It's getting me the remainder as 0. What's the order ID from the next one? 68,742 divided by 6. It's showing as 0 again. So what's the order ID from the next one? 68,748 percentage 6. It's getting me the remainder as 0 again. Right? So as you can see here clearly, hashing is working fine because as all these are giving me the remainders as 0, all these are placed into the bucket which is having 0 here. Let us verify the hashing for the next one. What's the order ID from this? 68,743 percentage 6. So the order ID, sorry, the remainder is showing as 1. So what's the order ID from the next one? 68,749 percentage 6. Again, the remainder is showing as 1. So what's the order ID from the next one? 68,755 percentage 6. Let's look at the order ID. Let's look at the remainder from this. It's showing as 1. Right? So now have a close look here. So as it is giving all the reminders as 1 here, all these records are placed into this bucket which is having 1 here. So the hashing is working perfectly fine. Now I'm interested in sorting, whether sorting is working fine or not. Have a look here, we can see 60,736, 60,742, 60,748. So the sorting is fine. How about for the next one? 60,743, 60,749, 60,755, right? So I can see that the bucketing with sorting is working perfectly fine, right? So there are some questions in the chat box. I'm going to pick up one by one. So there is a calculation involved for the bucketing calculation. I'll cover that shortly now. The other question which I've got is, let me paste these questions in here so that you can also see the questions. Bucket divides equally. So with respect to partitioning, if you partition based on geographical location, there are chances that the data might be not equally distributed. That's where we can use bucketing, which will make sure that the data is evenly distributed among the existing buckets. So the next question is this: why all the statements are default? So basically, some properties are set to true, some properties are set to false. So we have to check whether the property that we're interested in is already set to true or false. Only then we have to move further, right? There is no other way. But in the projects, right? So what already we'll have Hadoop admin team. The Hadoop admin team will take care about setting all these properties for you. As a developer, you don't need to worry much about it because most of the things that we are looking for right now, they will be automatically set once you join the project. So you don't need to worry much about this. But it's just a kind of extra check. If you have to debug certain things, right? You have to check these values. To answer your question in short, it's already taken care in the real-time projects. You don't need to set these. So there is one question in the chart called as, can hashing be performed on string data as well? I will answer this question practically shortly now. So right now it is sorting in the ascending order. Have a look here. 736, 742, and 748. This is ascending order, increasing order, right? Now I'll talk a little bit about this point. Can hashing be performed on a string data as well? So to answer this question, what I would like to do is, if you look at the data, we have a column called as order status column. I wanted to perform the bucketing now based on the order status column. Let us see the results. I'll take this query and I will try to define my table name. Let us give a different name, as I wanted to perform the bucketing based on order status column. I'm giving the name as order status. And then I have to mention the bucketing column name as order status, because we just want to test it out, but we are really not sure whether it works or not, right? And so let's say for simplicity, I'll give the number of buckets as 4. Let us create this table. In fact, this is one of the interview question, right? The interview question comes this way: can we perform the bucketing on the string based columns also, right? We'll answer that question practically now. Let's copy this, clear the screen, right click and paste it. So I have created this bucketing table with bucketing done on order status column. You can also describe this, describe formatted, orders buck, order status. You can see number of buckets is showing us 4. Bucketing columns is nothing but order status. Now I wanted to load the data into this table by using the staging table. So let's copy this query and go here and paste it. So have a look here again. The number of reducers is showing us 4. Number of files is also showing us 4. Let us verify the contents in the HDFS location. I'll copy this path. Right click, copy. TFS space -ls -h. So guys, what's your observation? I can see exactly 4 files. That is, I can see the buckets, right? I can see the number of files is showing us 4. But there is one problem here. Can anyone guess what the problem is? Look at their sizes.
Data is here.
Their sizes are not equal, right? So the fundamental concept behind bucketing is, the data is evenly distributed, but it's not getting evenly distributed, right? So that's the problem if you try to do the bucketing on a string based column, because hashing won't be applicable there, right? You will get the data unevenly distributed, which is not the desired feature of bucketing. Hence, we preferably not go with bucketing on a string based column. Okay. I hope now this question is answered. Right? Now I want to talk about the number of buckets. So how to decide the number of buckets? Number of buckets in Hive. There are a lot of factors that we have to consider before deciding the number of buckets, but there is one simple formula that we often follow in the projects, right? So first of all, what's the default block size in Hadoop? Default block size in Hadoop 2.x is 128 MB. Suppose I have a Hive table of size. Let us take a value, let's say 2300 MB, right? Now I need to calculate the number of buckets to define this bucketing table. So the formula goes this way. We have to decide the number of buckets n such that 2 power n. Okay, let's do one thing. Let's do this division first. So 2300 divided by 128. How much will this be? Let's do the calculation. So 2300 divided by 128. So this will be 17.9. So 17.9, right? So now I have to pick up a value of the number of buckets where this value is. So the formula goes this way: 2 power n must be greater than 17.96, 17.9, right? So we have to substitute each of these values. So let us try to substitute the values in the power of n. And first of all, always remember the number of buckets must be in the power of n. Number of buckets must be in power of n. No, sorry, not power of n, power of 2. What is the meaning of power of 2? It should be either 1 or 2 or 4 or 8 or 16 or 32 or 64 and so on. So number of buckets must be in the power of 2. So let's try to substitute these values. So again, guys, the power symbol, I'm representing it by using this symbol. The meaning of this symbol is nothing but power. So 2 power 0. So is 2 power 0 greater than 17.9? 2 power 0 is what? 1. Greater than 17.9. Is it true? False. Again, I'll take next one as 1. 2 power 1 greater than 17.9. It's nothing but 2 greater than 17.9. Is it true? False again. 2 power 2, 17.9. 4 greater than 17.9. Is it true? False. Again, 2 power 3 greater than 17.9. How much will this be? 8 greater than 17.9. Is it true? It's false again. 2 power 4 greater than 17.9. How much is 2 power 4? 16 greater than 17.9. Is it true? False again. So again, 2 power 5 greater than 17.9. How much will this be? 32 greater than 17.9. Right? So this is true. So in this scenario, we have to go with the number of buckets as 32. So this is how we'll decide the number of buckets in the projects. Right? I hope it is clear. Anybody have any questions still here? So again, as I told, I did not follow this number of buckets in today's example, but in the project, we will go with these numbers. Today I went with 4, 6, 8, blah, 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 but that's not the case in the projects. You have to pick up these values. It should always be in the power of 2. there are chances that this question might be asked in the interviews, and you have to explain in a similar fashion. You have to share your screen and explain in a similar fashion. That gives good impression. Right? Again, based on the partitioning concept and based on bucketing, I have got certain assignments for you. Right? I have one assignment on static partitioning, other one on dynamic partitioning. Also, a couple of assignments on bucketing and sorting. So what I would highly encourage you to do is go through the recording, practice everything, then come back to these assignments and try to answer these questions, right? And of course, I'll be providing answers to this in a separate file so that you can cross-check, right? And whatever data that you would require to solve these assignments also, I'll upload in the today's folder. You can refer it. So there is one question in the chat. Let me take that question. Just a moment. So this is one of the questions which I've got in the chat box. If the file size is 17.9, if you choose 16 instead of 32, what happens? So we won't get the equal distribution of the data, right? So that's where, that's where these formulas and everything have been inserted. So that's why you have to choose a number which is greater than that. You won't get the performance boost. Right? I think pretty much this is what I wanted to cover. If there are no other questions, then we are good to meet tomorrow then. Yeah. See you tomorrow, guys. Bye-bye.
Thank you.
See you. Bye. Okay, this is what I got in the chat. So if you apply partitioning on order status column, it's going to divide the data based on distinct values. In our case, we apply bucketing on order status. So no, basically number of files is decided based on the number of buckets that we give, right? So it's actually distributing all the records in an unevenly fashion, right? You can see all the records with respect to their order status are going and getting distributed in a random fashion, which is not the suggested one. Hence, in the projects, we will not go with string-based column. We will always go with the numerical column, such as order ID, in our case, as the bucketing column. Okay, guys, I think we are good for today then. So let us meet tomorrow. See you then. Bye.